Okay, so last video, we got to here, we got our central atom, we put in our dots, we got everybody to 8, everybody's really happy. Then we went and we counted from the periodic table, and the periodic table said, wait a minute, you can only have 10 electrons. Everything counts as 2, so we had 2, 4, 6, 8, 10, 12, 14. Way too many. So what the heck are we going to do? All right, so what we're going to do is we're going to add a bond. When you add a bond, it is what you call a double bond, because right now we have a single bond, and if we add one, we're gonna get what we call a double bond. But another exception for hydrogen, hydrogen cannot have more than one bond. So hydrogen cannot have double or triple bonds. It's just too little. So you don't get to add anything to hydrogen. You got to leave it alone. It's too little, can't handle anything, perfectly happy. So what we do is we're going to add a bond. So I could add a bond here, but it would violate the rule that hydrogen cannot have a double or a triple bond. So I'm kind of stuck. So once you have a hydrogen, then basically you have to leave it alone. So we've got a hydrogen there. I'm going to have to leave that side alone. So that means I'm going to have to put something here. And I'm going to add, like I said, we're going to add what we call a double bond. So we add a bond in between the carbon and the nitrogen right there. Not like that. So we're going to add right there between those two. And now we have a double bond. But here's what happens. When you add a bond, you're going to eliminate a pair of electrons from each side. So it's attaching to carbon. So I'm going to go up here and I'm going to get rid of those. And nitrogen. So I'm going to get rid of those. So see, I eliminated a set from each side, and then I'm going to recount. So let's count again. 2, that one's gone. 4, 6, 8. Each line counts as 1. 10, 12. 2, 4, 6, 8, 10, 12. So it might be kind of hard to see because I covered up right there and then right there. There we go. 2, 4, 6, 8, 10, 12. Everything counts as 2. Okay, now we're at 12. 12 is not 10. See, what I'm trying to do is I am trying to get over here to 10. We now have 12. So we just do it again. We add another bond. So I'm going to add another bond. That's going to make this a triple. So that's a triple bond. And then I have to remove a pair from each side of the new bond. So I take one from the left, I take one from the right. Now we recount. 2, 4, 6, 8, 10. Okay, boom, 10. 10 is what I wanted. And if I get 10, we're going to be nice and happy. So that means that this is the correct structure, right? We're down to 10. Okay, so let's go ahead and clean it up. Right, so let's clean it up. So what did it actually look like? Well, it looked like this. H. I'm going to go with a bit fatter pen there. So we're at 10 electrons. That's what we wanted. And let's go over here and let's write out what it looks like at the end. So it's going to be an H, single bond, carbon, triple bond, nitrogen, one lone pair. So if you look at this final structure, everything is pretty good. Everything's at 8. We're at 10. We're meeting all the criteria. Just that Mr. Reese didn't draw it very well, so we're going to try it one more time. That's a little cleaner looking. So we can double check. Okay, so remember, every line is going to count as 2, and the dots count as 2. So the hydrogen has 2. Okay, it's fine. That's all it wants is 2. The carbon, 2, 4, 6, 8. Okay, that's good. It wanted 8. Okay, so that's good. And the nitrogen, 2, 4, 6, 8. Okay, cool. It wanted 8 as well. There we go. That is a correct structure. So it met the target number, which is the value from the periodic table. So there's my target number right there, 10. And everybody has 8 except hydrogen, which has 2. So this is the answer from the notes. Okay, let's try another one, because that one was kind of complicated, right? We did a lot of stuff there. Let's go ahead and do another one. Let's do... let's go with a bigger pen. Let's do SO3 and see what that looks like. Okay, well, SO3 is pretty easy to figure out the middle atom because it's the first element listed usually, which is the sulfur. So that's pretty easy. We'll just put him in the middle. And remember, everything is going to be attached to the middle. So you have things attached like this. Everything goes to the middle, right? And so one of the mistakes students make is they try to put things in squirrely places. No, just put them attached to the middle. So I got 3 things. So I'm going to attach 3 elements, just like that. Okay, now we fill everybody up to 8. There aren't any hydrogens to worry about, so just remember they have little imaginary boxes around them. And so like there's nothing here, here, or here, so I need to fill those places up. If you find yourself adding more things than 4, more things than 4 sides can allow for, then that's a problem. So it's going to put a pair here, a pair here, and a pair here. Sulfur needs something on the top. Oxygen needs top, bottom, and right. This one needs right, left, and bottom. There we go. Everybody's at 8. Everybody's happy. So let's go figure out the target number. So what is sulfur going to contribute? And then what is oxygen going to contribute, except for there's 3 of those. So it's going to be whatever that number is. And we're going to multiply that by 3 because, see, there's 3 oxygens, right? And so instead of doing it 3 times, we're just going to take whatever number oxygen is times 3. Okay, so let's go look those up on the periodic table. And so here we go. Let's go ahead and zoom in on that. And let's go ahead and get rid of our stuff from last time. Let's go get rid of that. Okay, so let's put those back in there. So 3, 4, 5, 6, and 7. Okay, so we got to find oxygen, and we have to find sulfur. So here's oxygen. It's in column 6, and we'll look right below it. There's sulfur in column 6. So they're both going to give us 6 valence electrons. They're both going to give us 6 towards the total. So let's go ahead and zoom in on this. All right. Okie doke. So we said sulfur has 6, but then we had oxygen also had 6, but we're going to multiply that by 3, which is 18. Add those all up, 6 plus 18, 24 electrons. That is my target number. That's my target number, okay? Okay, so let's count. See what we got. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 20, 24. Oh, I think I miscounted. Gotta be careful counting. You can often miscount. That was my fault. Try it again. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. All right, counted it right that time. That's nice. I didn't mess that up. So we have 26 electrons and we need 24. So we get to make a bond somewhere. And where are we going to make that? Probably should erase those earlier. Okay, well, we'll fix it real quick. So where are we going to make our extra bond? We can make it anywhere. You can put it here, here, or here. It doesn't matter. So I'm going to put mine here. And we're going to get rid of an electron off of sulfur, pair an electron pair off of oxygen. So we have to get rid of a pair from each side. And if you recount, we're going to have 24. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Now I made a mistake over here. This should say 26 is what we had a minute ago. And I mistakenly wrote down 24. We want 24. That's a target. And if we count this, this is now 24. So this is the correct structure. So I can rewrite it and show you the correct structure. So we just kind of clean it up a little bit. It would be oxygen and then sulfur and then a double bond and then oxygen and my single bond down here. And then here's all the dots we had left. There we go. So there's your structure. All right, let's take a look at the last one on the example. Actually, I'm going to do a different one. You can work the example on your own. So let me do the last one here. NH4 plus 1. Okay, so we got to talk about that plus 1. So first of all, what chemical goes in the middle? Well, it has to be nitrogen. So let's put nitrogen in the middle and attach it to 4 hydrogens. So now if you look at this one, you can't have any dots because guess what? Hydrogen doesn't get dots. And nitrogen has 1, 2, 3, 4 sides of the box. So there's no adding of electrons here, no adding of dots because this one is stable. The hydrogens are happy. The nitrogens are happy. So let's look up the target number. So we have the nitrogen, and then we have the hydrogen, and whatever we get on the hydrogen, we're going to multiply by 4. Okay, so let's look those up. Well, hydrogen is in the first column, so it's going to be a 1. So here's hydrogen. And the nitrogen over here is a 5. So nitrogen is a 5, because in column 5, and 1 for the hydrogen. So let's go ahead and clean that up real quick. And 1 and 5. Okay. So with that thought, I'm going to go ahead and put a 5 here. And then this is going to be 1 times 4, which is going to be 4. So that's 9. But you have a plus sign. That plus sign means you actually have to take 1 away. We do the opposite. So minus 1, 9 minus 1 is 8. Well, what do we have here? 2, 4, 6, 8. Boom, perfect. You don't have to add any bonds. It works. But what you do have to do is put a bracket around it and put the charge on the outside. So if you have a charge, you have to put a bracket around it and put the charge on the outside. So that's only if it has a charge. So like this and a plus 1. So I think I'm going to pause it here. 3 practice problems for you should be good. You don't always have to add bonds, but you do always have to check the target numbers